All right, let's jump right in. We're tackling one of JavaScript's most powerful and, yeah, sometimes most confusing features, closures. But stick with me because by the end of this, you're not just going to get what they are, you'll see why they're so absolutely critical to the language.
I mean, just let that sink in for a second. A function with a memory. It sounds kind of like magic, right? A piece of code that remembers stuff even after you think it should be long gone. Well, it turns out this magic has a name, and we're about to pull back the curtain and show you exactly how the trick works.
Okay, first up, functions with memory. This right here is the whole heart of what closures are all about. It's what lets you write some really, really slick code. So let's break it down.
So, here's the easiest way to picture it. Imagine a parent function and a child function inside it. A closure is what lets that child function remember and use its parent's variables even after the parent function is totally done, finished, gone. The child basically keeps a little souvenir, a closure, of the place it came from.
That definition is a good starting point for sure. But, the best way to really, truly get this is to see it in action. Talk is cheap, right? Let's look at some code and make this real. All right, check this out. We've got this outer function. Inside, it declares a variable, counter, and sets it to 0. Simple enough. Then, inside that, we have an inner function. All it does is add 1 to counter. But here's the kicker. Look at the last line. The outer function doesn't call inner, it returns it. It hands the entire inner function back as its result. Okay, so now we execute that line. We call outer, and we save whatever it returns into a new constant called count. And since we know outer returns the inner function, count is now basically a new name for our inner function. But here's the important part. Listen up. At this very moment, the outer function is finished. It's run its course. It's off the call stack. Poof, gone. So, here it is. The big question. That counter variable, it was created inside outer, but outer is gone now. So, shouldn't counter be gone too? What do you think is going to happen when we actually call our new count function? Boom! There it is. We call count and we get 1. How? The inner function, our count variable, it remembered the counter variable from its birthplace. Even though it's home, the outer function is totally gone. That is a closure. So, what happens if we do it again? Let's call count again. And look at that, we get 2. Now this is where your mind should be blown. It didn't start over at 1. It didn't reset. The function didn't just remember that counter was a thing. It remembered its last value and updated it. It's got a persistent state. And let's do it one more time just to be sure. We get 3. This just perfectly shows what's happening. Our count function has its own private little memory, its own state, that sticks around between calls. That is the power of closures. So what's the secret? How is this even possible? Well, it's not magic, I promise. There's a rule in JavaScript that makes this happen, and it's called lexical scope. And really, that's just a fancy term for a simple idea. Scope is all about where the code is physically written. This is the one thing you really need to get. Think of a JavaScript function like a person packing for a trip. When that function is created, it packs a backpack. And in that backpack, it puts all the variables that are hanging around in its environment. And it carries that backpack with it for its entire life. So it doesn't matter where you send that function, where you call it, it will always have access to the stuff in its backpack from where it was defined. And that brings us to the fancy technical definition, the one you use to impress people. A closure isn't just the function. It's the function plus its entire lexical environment, that backpack we just talked about. Remember that one. It's a game changer. All right, theory's great, but let's get real. How does this actually affect your day-to-day coding? Well, knowing how closures work is half the battle. The other half is knowing how to avoid the common mistakes and traps people fall into all the time. We're going to look at 3 big ones. First, thinking that a variable is going to reset when it won't. We kind of just saw that with our counter. Second, and this is a classic interview question, is getting weird behavior with loops. And third is the danger of memory leaks, which is a serious performance issue you gotta watch out for. Okay, look at this. This trips up so many developers. On the left, we're using var inside a for loop to schedule some timeouts. The problem is, var doesn't create a new variable for each loop. So all 3 of those timeouts are looking at the exact same I. By the time they actually run, the loop is long finished, and I is sitting at 4. That's why you get 4, 4, 4. But on the right, we use let. Let is block scoped, which means it creates a fresh, new I for every single pass of the loop. Each function grabs its own copy of I, and that's how we get the 1, 2, 3 we were actually hoping for. Huge difference. Okay, so you've got the what, you've got the how, and you know what to avoid. Now for the fun part. how to take all this knowledge and absolutely nail it in a technical interview.
Here's your game plan. Start with that pro definition, a function plus its lexical environment. Then, right away, talk about what you can do with them. Mention things like data privacy, how you can create variables that can't be touched from the outside. Talk about function factories, functions that create other functions. And if you really want to show off, bring up advanced patterns like memoization or caching, where you use a closure to remember the result of an expensive calculation. That shows you're not just reciting a definition, you actually know how to apply it.
So at the end of the day, remember this. Closures aren't just some weird trivia question for an interview. They're a core part of JavaScript that basically gives your functions superpowers. The power to remember things, the power to keep things private, and the power to write way more powerful, elegant code.
Honestly, once you really truly get closures, it unlocks a whole new level of programming in JavaScript. It's one of those concepts that, once it clicks, it just changes the way you think and the way you code. So, the only question left is, now that you get it, what are you going to build?